Okay, welcome back. Today we're going to go over some of the exponent laws that you've learned in the past in order to simplify exponential expressions. So there's a few that we need to review here. The first one being when you have the same base, so the bottom number is referred to as the base, and of course the little numbers up in the air are called the exponents. Altogether, it's called a power. So when you have the same base and you're multiplying in between, you can combine them into a single base. So you can write it as a single base of a, and the overall exponent is going to be the sum of those two exponents together. So when you have the same base and you're multiplying, you keep the base and you add the exponents. Again, feel free to pause, copy down, fill in as we go, or print. Also, you can combine powers when you have the same base and there's division happening in between. So again, what happens is you keep the base the same. So we keep the a at the bottom as our base, and it's the first exponent minus the second exponent. So it's the first exponent minus whatever. So subtract whatever the second exponent happens to be. And likewise, if you have one base, but if he has two exponents on him or more, doesn't matter how many exponents, and you just want to write it as a single power, again, one exponent, we keep the base, and this is where we multiply the powers together. And of course, the order you multiply in and the order you add in does not matter. But when you subtract, it's always the first exponent, so the exponent on top minus whatever the exponent on the bottom happens to be. So you could be minusing a negative here. Also, if you recall, distributive property also applies to exponents, meaning if you have two different bases to the same outside exponent, what happens is that outside exponent gets applied to both bases. So that's one way that you can distribute and figure out what the overall value is going to be. And the same thing if we were dividing. It doesn't have to be multiplying. It could be dividing as well. Because they were both in the bracket, A gets the power of n on him, but B also gets the power of n on him. Now, again, these are different bases, so you can't combine them, but you can distribute the overall exponent. You may also have remembered that anything, it doesn't matter what the base is, to the exponent 0 is always going to be worth 1. So the answer is 1. Not the exponent is 1, but the whole answer works out to be 1. And one way to think about it is if you had x to the power 4 divided by x to the power 4. We know that if we're going to use our division rule here, we have the same power, x and x, the same base. What we do is we keep the base and we subtract the exponents. And we know that 4 minus 4 is 0. So what x to the 4 divided by x to the 4 is really worth x to the 0. But x to the 4 over x to the 4 is also x times x times x times x, all over x times x times x times x, because that's what x to the power 4 means. It means x times itself 4 times. And because we're multiplying in between, what this allows us to do is to cancel out, simplify out the same things that we see top and bottom. So x cancels with x, x cancels with x, x cancels with x, x cancels with x, leaving ones in behind, and 1 times 1 times 1 times 1 is 1, over 1 times 1 times 1 times 1 is 1. So basically, this also is equal to 1, but it was equal to x to the 0. So they must be equal to each other. If both things are to be true. If this equals x to the 0, but this also equals 1, then x to the 0 must also equal 1. So that's why anything to the power of 0 is worth 1. Negative exponents. So if you happen to see a negative up in the exponent section, this is important that you realize that what you need to do is you need to use up that negative like a ticket. And that makes you have to flip the base to its reciprocal. So whatever the reciprocal of that base would be, it was just an a here, so we know that there was a secret 1 underneath. So we flip, a over 1 becomes 1 over a. And what that now does, or what it means, is that now this negative exponent has now become a positive exponent. So the flipping of the base uses up the negative like a ticket in the flipping. So a over b to the negative n would be worth the same thing, that's why there's an equal sign here, of b over a. So the b went up, the a came down. So there's the reciprocal, and now it's no longer a negative exponent. So you need to be able to go back and forth between these two different things. So for instance, 2/3 to the negative 2 is the same as 3 on top of a 2 to the positive 2. So these both mean the same thing. They both are worth the same amount, and you need to be able to flip back and forth. All right, so now let's actually go ahead and start applying these rules as we simplify different expressions. So we have some examples here, and again, copy out as you go ahead, or if you didn't, you could have printed it out already. So here we have express as a single power, then evaluate. So basically it's saying simplify first, then figure out the answer. So the first one, 2 to the 4 times 2 to the 3. So we keep the 2 as the base, and we add those exponents, which means we have 7 2's altogether. Now, you don't have to write this middle step. This middle step is just me showing you how I'm getting my final answer. In the next case, the base is -2, the base is -2, and we're multiplying in between. So we keep that base of -2, and again, we add those exponents. Notice the use of the brackets. The bracket was important here because it means the negative belongs to the 2. It also gets the exponent. When you don't see a power, an exponent, you know automatically it's a 1. Nobody writes 1's down when they're exponents. So if you don't happen to see anything, you know to count it as a 1. So here we have -7, here we have -7, we're multiplying, and we add those exponents. So 4 plus 1, again, I'll show my work, to come up to the total of 5. And the last one on this line, -3, -3, and that is a division sign, just in case you can't see it. -3 is the same base, 6 minus 4, so we get -3 all to the power of 2. And make sure, again, you're using the bracket. This is another division symbol. 7 to the 10 divided by 7 to the 6 is 7 to the 10 subtract 6 is 7 to the 4. Now it's saying evaluate, so I'm going to go back and show you how to do it on your calculator to get a quicker answer. In F, we have double exponents, so what we do is we keep the base and we times those exponents together, and that gives us 12 as a power. Here, again, double exponents, 2 and a 3 on the -3 base, so you need to know what 2 times 3 is. And that's, again, going to give us the full answer of 6. So what I want to show you on your calculator is your exponent button. Now mine happens to be this up arrow. So look for the up arrow, look for y to the x. Yours might also look like x to the y. Okay, so these are the buttons that mean exponent on most calculators. So it might look like this, it might look like this, it might look like this. So you put any base you want to any power. So it's not the specific one that has a 2 or a 3 on it. This is only for squaring. And obviously the one with the 3 is only for cubing. We want to make sure that we can do any power we want. So 2 to the power of 7, 2, then whatever exponent button you have, exponent 7, 128. The next one, -2 to the power of 5. So you should use brackets because you know the negative gets included. And power of 5 is -32. So I would like you to memorize 2 to the power of 5 is 32. That's always a good one to memorize because powers of 2 are used a lot. And that way, if you know that 2 to the 5 is 32, if I asked you what 2 to the power of 6 is, you could start at 2 to the power of 5, 32, and just times this answer by an extra 2 to get 64. 2 to the power of 4 would be 1 less, so 1 level under 32, so you would divide by 2 to get 16. So 2 to the 4 is 16, 2 to the 6 is 64, and you could build from there. So it's a good starting point. if you memorize that 2 to the 32 is 32. Now, also, if you have a negative, something to pay attention to, if you have a negative base, like -1 here, and you put an even exponent on it, so any even exponent, I put 100. You're not going to sit here and going to go negative times negative times negative times negative times negative 100 times. You're not going to do that. That's going to take up way too much time. But if you just pay attention that that's an even amount, remember that every time that they pair up, it makes a positive. Every time they pair up, it makes a positive. So every pairing, it's going to use up 2 negatives. Well, an even exponent means there's going to be, everybody's going to have somebody to pair up with. So there's going to be no leftover -1s. So we know that your final answer should be positive in the end. Versus -1 to the 99. 99 is odd. So that means 1 and 2 are going to pair up, 3 and 4 are going to pair up, 5 and 6 are going to pair up. So there's going to be the 97th and the 98th -1 are going to pair up, but the 99th -1 is going to be left over. So we know that our final answer is going to be negative. So those are good little look fors. Let's finish this up. -7 to the power of 5. So again, negative key, 7 in brackets, power of 5 is, we would expect a negative answer because it's an odd exponent. -16,807. -3 squared. So again, this doesn't mean 3 times 2. This means 3 times itself. And the last decision you need to make is, should that negative stay in the final answer? But 2 is an even number, so I know the negatives are going to use each other up. They're going to pair up, leaving me with no negative left over, so it's going to be a positive answer. 7 to the power of 4 is 2401. 2 to the power of 12, again, you could start from here and keep counting. This is going to be a large number, 4096. And lastly, -3 to the power of 6. So I know my final answer is going to be positive something, whatever 3 to the power of 6 is, and 729. So I knew it was going to be positive because, again, even though the negative got repeated, it was repeated 6 times. So that means pairings of 2 would all equate, and you'd be left with no negative left over. Okay, so now moving on to just simplify. You notice that these are letters in most cases. So when they have letters in there, there's nothing to do. Now, if they're numbers, that means you do actually figure out what the answer to the numerical coefficients are, or if it's just numbers in general. So here we have an outside exponent of 3. Remember the distributive property. That outside exponent of 3 belongs to everybody who's inside the bracket. We multiply. So this is x to the power of 2 times 3, and this is y to the power of 7 times 3. So I'm just showing my work here. Most of you are just going to write x to the power of 6, y to the power of 21 right away. So that's fine too. I'm just showing you where I'm getting my answers from. Again, this outside exponent of 2 belongs to the 5, and he belongs to the x. So that's 5 squared, and x cubed also squared. So that's 25x to the 6. So a lot of students will just forget about the 5 and they'll just write 5 down here. But the 5 also gets squared, so you've got to change them into a 25. So again, the 4 on the outside belongs to everybody on the inside. So this is 2 to the power of 4 over 3 to the power of 4. So you figure out your top answer, you figure out your bottom answer. Well, 2 to the power of 4, like we said, 2 to the 5 is 32. So 2 to the 4 is going to be 1 under 32, so divide by 2, 16. So 2 to the 4 is 16. 3 to the 4, now that's a bigger number. There you go, 81. And reduce if you can. In this case, you cannot reduce, so you're finished. Here we have -4 over 5 times itself. So those people that like to see it written out, this is what we're doing here. We're repeating the negative twice, repeating the 4 twice, repeating the 5 twice. We're distributing, in other words. A negative times itself is positive. 4 times 4 is 16. 5 times 5 is 25. So positive 16 over 25. And when you have multiple things to complete, So here we have 7, 7, 7. So obviously we have the same base. Let's clean up the numerator first by adding 15 plus 5 gives me a total of 20. And now I can combine top and bottom. Top exponent minus bottom exponent gives me just 7 squared, which is a nice number like 49, 7 times itself. Remember, it's not 7 times 2, it's 7 times itself. All right, some questions in your homework are going to look like this, where they ask you to simplify and then evaluate for certain values that they give you for the letters. Do not sub in first. You simplify first. So you have to use your exponent laws to clean this up first. So what I suggest you do is one of two things. You can put the W with the W and the Y with the Y, and then distribute the outside -2, or do the reverse. Distribute the outside -2 to everybody, so times this by 2, times this by 2, times that by 2, times that by 2, and then clean up your W's and then clean up your Y's. Your choice. They both get you to the same place at the end, but I think most people are going to clean up the bracket first. So W -2 minus whatever the bottom exponent happens to be. So we're minusing a -4. -2 subtract -4. And the Y, 6 subtract 5. And that still has the outside exponent of 2 on it. So by showing my work, I'm hopefully not going to get the integers wrong. -2 plus 4 is 2, and 6 minus 5 is 1. Now, notice I'm not even bothering to write the number 1 down as the exponent on the Y. Now I distribute this outside exponent of 2, which puts a 4 on the W and a 2 on the Y. So that's my simplified answer. You can't combine a W and a Y. They're different. They don't go together. But I know that W is worth -3. So now I replace that because that's what the question told me. And a Y is worth 2. So -3 to the power of 4. Well, 3 to the power of 4 is 81. But again, on your calculator, if you're not sure, you can do it with your brackets. And notice again, it's positive 81 because it was an even exponent. And we're going to multiply that with whatever 2 to the power of 2 is, which is 4. So just times that by 4, and you get your 324 answer. Alrighty, so what I suggest you do is look over that again and then come back and we'll continue on with the second half.